Okay, let's go and get started today. It'll be relatively quick to go through what we need to get through today. Essentially what I'm going to do is give you a lab today to work on, kind of explain the lab, and then let you work on it. So let's go ahead and get started. So to start off here, the lab is kind of an inter-process communication lab for connections. And if you remember the way connections work, at least in the Python multiprocessing module, it's clients and listeners. But as an aside, you could also implement this using just sockets. There'd be a little more work with sockets because you'd have to serialize the data and deserialize it yourself. But clients and listeners kind of does that for you. So I would suggest doing this with kind of the connection client and listener objects. All right, so let's take a quick look at what we're going to do. So before we look at the lab sheet, let me just go through a couple things here. So the first thing is we're going to write a program. It's going to have multiple processes and connection objects between the processes with both kind of a listener and clients that connect to that listener. And we're going to make this kind of multiplayer game of tic-tac-toe. All right, so to do that, we're going to make two types of program. We're going to make a server program. We're going to make a client program. So the server program is going to kind of be like a game server. It's a really simple game server, but it'll still be a game server. It'll maintain the board state. It'll communicate with the clients. It'll tell them whose turn it is. It'll get their move. It'll update the board state and then talk to the other client. So the client is just going to connect. It's going to allow the user to make a move when it's their turn. It's going to show them the board state and then kind of continue until the game is over. So one thing to note is in order to play, two players have to connect. So two clients have to connect to the server in order to play a game. You need two players to play tic-tac-toe. Okay, so here's kind of a picture representation of what we're talking about. We've got the server program that runs. The client programs are going to be the same program, but they're each going to connect to the server. The server then is going to serve the board state and say whose turn it is, get the response, tell the other one it's their turn, get the response, and so forth until the game is over. So the server is going to be written with a listener. It's going to accept connections. The clients are going to be written with client objects that kind of connect and then talk to the server to get their information. Okay, so let's take a quick look at the lab sheet here because that's probably the easiest way to kind of get an idea of what the lab should be. So let me switch over to the desktop. Let me switch to the lab sheet. So here's the lab sheet. So one thing to notice about this is it says exactly what we said. The thing to notice here is I give you some steps here that can help do that. So in other words, the server program, the client program, you're going to run two instances of the client, one instance of the server. So essentially what the server needs to do is create that listener that can be on your local machine, meaning localhost or 127.0.0.1, and some port number. Now the port number, you can pick whatever you want. 0x1234 could be whatever port you want. One thing to note that if you pick a port number and it's not working, it could be that port is already in use on your machine by something else. Like for example, if you have some web server running on your computer and you pick port 80, there could be an exception that gets thrown saying that port is not available. So just be aware that you pick some port number. It doesn't matter which one as long as they're the same port that this tries to connect to as the listening port on the listener that's up here. Okay, so then we're going to accept two connections from two client programs. In other words, we listen, we accept connection 1, we accept connection 2. We then pick one of the clients to go first. We send them a message, meaning that we're going to send something across that connection that tells them that it's your turn. Here's the board state. They're going to make a selection as to what move they want to make. We're going to then update the board state, send a message to the next one saying it's their turn. So that's the basic idea, and that will repeat until someone wins or the entire board gets filled, at which point we'll send a message saying the game is over to both clients. Here's who won. If client 1 is the winner, tell them that. If client 2 is the loser, we'll tell them that, and they'll just be able to display that on their screen. So one of the things I would suggest for this is kind of mapping out the order of communication, who gets what when. So rather than just throwing together code and trying to do it, try to think ahead. Now, when you go to write programs, as we've learned with other concurrent programs, that we're going to need to kind of map out who does what when, because we've got two different programs that can be in any position through this thing. So we're going to need to be a little bit cautious about how we plan that out. Now, probably the best way to get an idea for what we're talking about is to look at this kind of example output. This is what a client might see. So it says connected to server, waiting for other player. And then after the other player joins the server, it tells them you're X, it's your move. They're going to then pick a move. In this case, I just numbered the cells 1 through 9. They type in their move, say they want move 5. That puts an X because they're X into cell 5. And then it says waiting on opponent. So now at that point, the server would send this same message to the other player, but the other player would see this as the board state and it'd say, you're O, what's your move? So it would say you are O, it is your move, but it would show this as the board state. They would then pick any of the numbers except for 5. They could pick 1, 2, 3, 4, 6, 7, 8, 9. And then they'll make a move. And then in this case, they picked 1. So you notice the board now comes back, says you are X, it is your move again. And notice that can be in a loop. You're probably going to want to loop around that. And that would be their turn, and they could pick, I don't know, like 9 or 8 or 7 or any of them except for 1 and 5 that are already taken. And that will continue until the game ends. So that's the basic idea behind the lab. One thing, though, when you look at this lab sheet, notice there's a second page here that I do have some hints there. The hints are kind of make sense, but read through those anyway. The other part of this is, notice I gave you a chance to get up to 15 bonus points here, which is a considerable amount considering the lab is only worth 20. So you can get almost a whole lab's worth of bonus points here, which can be really useful. Now, the bonus is write a graphical version of it where you click on the boxes to make your moves. The second bonus is to include the entire board and rules for ultimate tic-tac-toe, which a lot of you are familiar with because we did a house challenge with that previously. But here, that ultimate tic-tac-toe kind of thing here, I put a link to the Wikipedia entry, and if you want to look at that or do that bonus, go and click through that. But essentially, it's a tic-tac-toe board filled with tic-tac-toe boards. And there are some other rules with you make a move and where that forces the other opponent to make a move. So read through that, implement that, and you get some bonus points for those kind of things. But once you have the basic idea and the basic thing working here, it's not too difficult to then convert that into either a graphical version or modify it in such a way that it has a larger board state and a larger set of rules. And the cool thing about using those connection objects and listeners and clients is that Python handles all of the serialization of those objects for you. So you can pass in something like a dictionary or a list or a dictionary that has a key that associates with the list. You can pass in all kinds of objects like that, and it will handle serializing that for you, transporting it to the other end, deserializing it, and then making it available as the same object. So it's like we're pushing objects through from one process to another process, which is actually a really cool thing. All right, so let's quickly go back to the lab sheet here. And really, that's it. So what you're going to do is work on that lab today. Try to get that completed. It's due next week. But I'd suggest going ahead and working on that. If you have questions, post them in the comments here or send me an email. There's also the forum on the course page you can post in. But let me know if you have things. And also don't forget that going ahead and working on that now will give you a chance to then put in a little bit of extra work to get some extra bonus points. So don't forget that there are bonus points available, which could be helpful toward the end of the semester. So go ahead and work on that. Let me know if you have problems or questions. And other than that, stay safe, and I'll see you next time on here.